Hello students and welcome to Unit 7, Lesson 3B, Part 2. So just to recap, we have been learning about how to solve quadratic inequalities. The first method that we looked at was by graphing. This is especially useful if we have a quadratic inequality that has the two variables. The second method that we looked at was solving by roots and a test point. This is especially useful when we have the inequality with relation to 0, and is probably the most applicable one for this course. Last method that we looked at, method 3, was case analysis, looking at the two cases. And so for both of the specific factors, and then the area, if it has an area that overlaps, like there's values of x that satisfies both the cases, then that area is the solution to the inequality. This last method that we're going to go through is going to start off looking very elaborate. However, it is very useful in solving inequalities, especially ones that have a degree even more than 2. So you can use these to solve cubic inequalities. Exponents of 4 and 5. You can use this as long as you can factor the expression. So to explain this one, we're going to start off with the exact same inequality, quadratic inequality, that we've done the other 3 methods too. So by now you probably know the answer already, but that's not the point. The point is going through how we can apply this method to the same inequality, and we should always get the same answer. So the first step to solving with sine analysis is to break that down or factor it into the two factors. And from here, we're going to look at the two factors more specifically. It's easier for me to just kind of write this out because you can't see me pointing to them. So looking at, this is a plus, looking at that first factor, x minus 3, we know that when x equals 3, the value of that specific factor will be 0. And if x is more than 3, so like 4, 5, 6, 7, 5,666, you're going to have a positive value. Now this is sine analysis. We don't actually care about what value it ends up being. We just want to know what the sign is, positive or negative. And if x is less than 3, it's going to be negative. So for example, if x is equal to 0, 0 minus 3 is -3. That's a negative value. So you can always use a value that's, so for example, when we're doing x is less than 3, just pick a value for x that is less than 3, like -20, and throw it into this factor, this x minus 3 factor. Is it positive, and is the result positive or negative? And that can help you figure it out as well. So we're going to do this next one and do the same thing. So the place you start out with is where it is equal to 1. So when x is when it is equal to 0. So when x is equal to -1, the overall factor of x plus 1 will equal 0. When x is more than -1, so let's say 3. What is the overall sign of that factor? So 3 plus 1 is 4. That is a positive value. It's going to be positive. And then when x is less than -1, it's going to be negative. Okay. So I want you to think about that. We've kind of broken that apart, and I am breaking this apart quite a lot. We're going to put it all together in the next example. Okay. So I'm going to look at these signs. I'm going to analyze these signs and look at them together. So I'm going to analyze them. I'm going to do this. I'm going to try to color code it for you guys. We'll see how good I am at doing that. So we're going to look at that x minus 3 factor first. Okay. And the important point of this factor is that 3. So when it is equal to 3, it is the overall, when x is equal to 3, the overall factor of x minus 3 is equal to 0, because 3 minus 3 is 0. And again, if it's above 3, it's going to be positive. If it's below 3, it's going to be negative. I'm just going to put a couple negatives here to represent that. Okay, so just looking at that factor. Now, just looking at the x plus 1 factor, the important number in this case is -1. So if this is a positive 3, I've kind of like taken the same number line, just kind of broken it apart into 3 instances so we can look at them separately. I'm going to put the -1 here because again, it's the same number line as that red number line. I'm just kind of looking at it again separately. Okay, so when x is when x is equal to -1, the value of that factor is 0. When x is equal to -1, the value of that factor in blue is going to be positive. So I'm just going to stick some positives up here, onwards to infinity and beyond. And if it's below -1, the value of that blue factor is a negative. Okay. So now we're going to put those together because we have this factor times this factor. That's what factors are. They're being multiplied together. And we have these two important points, -1 and 3. So looking at this, if the first factor, x minus 3, is negative, and the second factor, x plus 1, is also negative, a negative times a negative is a positive. Looking at the area between -1 and 3, that top factor, that red factor, is still negative. But the second factor, the blue factor, if it's below 3 but above -1, is positive. And a negative times a positive is a negative. And finally, that last one, when it's above 3, both factors are going to be positive. And overall, that means overall, the inequality is going to be a positive value. They kind of alternate, so you're going to kind of notice that after a while. Right? So we're going to go back to the whole point of this. We had x minus 3, x plus 1 is less than or equal to 0. Less than or equal to 0 means we're looking at this. What value of this will it equal a negative value? Because it's negative that is below 0. We already know where it equals 0. It equals 0 with these roots. This is where it equals 0. So these numbers need to be in our answer in some place, shape, or form, but we need to know what values of x will make it below 0 as a total inequality. So the only area that it ends up being negative is this area here, which is between those two important points. So x needs to be between or equal to -1 and 3. And putting this in short form, we're going to use a square bracket because it can be equal to -1 up to and including +3. So that's the condensed form. And that is sine analysis. Let's look at a couple more examples. Let's do this one here. And the reason why I want to do a couple more examples is to show you how you can use this for a little bit more complex inequalities where the other ones might not be as helpful. Okay, so let's look at example 3a. You have a negative in the a position. So the first thing you're going to do is you're going to factor out that negative, and it's going to become a positive x squared minus x minus 12. Okay, and then you're going to factor that quadratic in the brackets. Two numbers is going to be x minus 4 and x plus 3, less than 0. Okay, so if I'm looking at a number line, my important points are +4 would make that one equal to 0, and -3 would make that one equal 0. But we actually have 3 things that are affecting the sign, because this is sine analysis. We have this sign here, this factor here, and this factor here. Now, no matter what the value of x is, that first thing, this negative here, no matter what value of x we're looking at, it's always going to be negative. Okay, no matter what value we're looking at. And we know that if x is -3 or +4, that the value is going to be 0 because those are our roots that we found by factoring. But now let's look at just that green factor, the one I highlighted in green, x is 4. So we're looking at this point here, which is kind of messy, but there's the 4. If x is more than 4, it's going to be positive. Plus, if it's less than 4, it's going to be, overall, that factor in green is going to be negative. So I represented that on the number line. So now what I'm doing, instead of breaking it into 3 separate number lines, I've actually squished it and putting it all into the same number line to make myself more efficient. So now I'm going to look at that last factor, that one where the root is -3. If x is more than -3, that factor that I've circled in blue will be positive. And just keeps going up, positive. If x is less than -3, that blue factor will be negative. So now what I've done is I've outlined the different signs, the sign analysis for the 3 components of that inequality that will affect the sign of it. We don't care what the value of it is because that is indicated with the sign. Because there is also no specific value that's a solution. There's a range of solutions. So looking at that area below -3, you have a negative times a negative times a negative. So a negative times a negative is a positive, and a positive times a negative is overall a negative. So if you have an odd number of negatives, the result is a negative. If you have an even number of negatives, the result is a positive. So this section here would be a positive. So negative times a negative is a positive, and a positive times a positive is a positive. And that area above 4, you only have 1 negative, so the overall result is a negative. So now we've got our sign analysis. We've analyzed the areas of where the signs will be negative or positive. Now we have to figure out what that means in terms of solutions. So if I look again at this, it was less than. So I'm looking for areas where it's negative. So this inequality will be negative below -3 and above 4. So to say that, we would say x is less than -3. It's not equal to, because it's not equal to, we're not using an equal to sign here. And x is over 4. Now, to be more thorough with our answers, technically below -3, it would go all the way to infinity. So another way of saying this is that x is between -infinity. That is one of those signs right there, and -3. And for the second one, x is between 4 and positive infinity. And to say that in condensed form, we always use a circular bracket with infinity and negative infinity. And we use a circular bracket when it is not equal to -3. And to include it with that other component, we say or with a mathematical symbol, which looks very similar to a U. So it has to be below -3, or it has to be above +4. So again, a circular bracket because it can't be equal to 4, comma, positive infinity, and another circular bracket. So we're going to skip this next example. And that's the final answer. That's how you would state that final answer right there. Gorgeous answer. We're going to do this C next. All right, so C is actually missed. That's not supposed to be in there. So I'm just going to rewrite this the way that I kind of wanted to. Okay. So if you notice about this, it's not a quadratic, right? The highest degree is a 4, not a 2, but we can still use sign analysis to find the solution of this inequality. The first thing we're going to do is fully factor. The 2 factors I've written out are difference of squares. So I can go further and write x plus 3, x minus 3, x plus 1, x minus 1 has to be greater than or equal to 0. So greater than 0 means that we're looking for positive areas where the overall sign is going to be positive. That's where it's over 0. And of course, where it's equal to 0 are going to be these roots, which we can actually find right now. The root for this first factor is -3, +3, -1, +1. So I'm going to put those on this number line, starting with -3 and going up in numerical order, not the order of my factors. There we go. So these are our 4 roots. That is where, if x is equal to any of those numbers, that is where the inequality will equal 0. So those numbers need to be in our solution in some place. Okay. The next thing we're going to do is look at each of these factors and how it will be, and where it'll be positive and negative. So let's look at this first one, -3. We don't care about the other numbers on the thing. We're just looking at -3. If x is more than -3, this factor that I've circled in purple will be positive. So I'm going to write a plus in all the sections above, because I know I'm going to be looking at each of these sections individually. If it equals -3, of course, it's 0. If it's below -3, that purple factor will be negative. Let's look at this second factor, x minus 3. That means the root is 3. So if x equals 3, this factor that I've circled in red will equal 0. If x is larger than 3, this factor, this red factor, will be positive. If it's less than 3, this factor will be negative. So below this point, below this 3, this factor in red will be negative. And that's a negative, just doesn't look like it. Okay. Now let's look at this factor in green. Okay. So the root associated with that one is -1, because when x is -1, this factor that I've circled in green will be equal to 0. If x is larger than -1, this factor in green will be positive. So I'm just doing pauses to the right. If x is less than -1, this factor that I've outlined in green will be negative. And that concludes that factor. We got one more to go. Hopefully you're following along with me. And we're going to look at the root 1, because when x equals 1, this factor that I've circled in blue will be equal to 0. If x is more than 1, the blue factor will be positive. That is a plus. If it's less than 1, that factor in blue will be negative. So with respect to this point right here, everything below will be negative. And now I've analyzed the signs for my individual factors, and now I want to look at the overall result. Remember, if you have an odd number of negatives, the overall result will be negative. And if you have an even number of negatives or no negatives, the overall result will be positive. So below -3, a negative times a negative times a negative times a negative means it's going to be positive. For that, between -3 and -1, you have 3 negatives. So the overall result is going to be negative. For -1 to 1, you have 2 negatives. So the overall result is going to be positive. In the next section, 1 to 3, you only have 1 negative, so the result is negative. And above 3, everything is positive, so you have a positive. Okay. Notice they kind of alternate. All right, so this question was asking about where are the solutions, or we're looking for the solutions where we will get values that are equal to or more than 0. More than 0 means where is it positive? So our solutions are positive here, in this section here, and this section here. So to say that in math speech, if I can get my pen back, to say that in math speech, we have this section here where it was -infinity equal to -3. It can't actually be equal to -infinity. I shouldn't have written that. Take that out. And then it was this middle section here where x was between -1 and 1. And of course, because it's greater than or equal to 0, we're going to put those lines under our inequalities as well. And then that last one, it goes from +3 to +infinity. And of course, you can never equal infinity. So how you would say this in condensed math speech is circular bracket, negative infinity, comma, -3 square bracket, because it can equal -3, or square bracket, -1 to 1 square bracket, or square bracket 3 to positive infinity circular bracket. And that is our final answer. So hopefully that helps. The last example is, I'm not going to go over it in the notes, but it applies the same way. So you would factor that denominator and you would have a numerator divided by a denominator, but in the grand scheme of things, you treat it exactly the same. You're just looking for the number of negative factors versus positive factors for each section. So where it would equal a positive or a negative, and where it has values that have even number of negatives, it'll be positive, and if it has odd number of negatives, it'll be negative, because a negative divided by a negative is a positive, and a positive divided by a negative is a negative. So the same rules apply for determining the overall sign of the inequality. All right, you can try it on your own. The answer you should get for D is negative infinity, comma, -3 square bracket, or square bracket 2, comma, 3 square bracket. Okay, that's the answer you should get for D. Right, so for practice, I would like you to do the following questions, except for I've already assigned 6. So you're going to do number 5 and 8 to 10. 5 is specifically about sign analysis, and 8 to 10 is overall summarizing all of lesson 3, which includes the 4 different methods: graphing, roots and test point, case analysis, and sign analysis. Please let me know if you have any questions. I hope you found this helpful.